There's a reason why this question is so intriguing. It defines how we see ourselves. Finding life would greatly alter our worldview and our place in the cosmos. It would change everything. Space is vast, full of billions of habitable planets and potential life forms, yet we've never detected any. It's the great silence. The perplexing nature of this is known as the Fermi Paradox. There are many theories to explain this paradox away. Maybe we're too far away from one another, or we're being isolated on purpose, or we haven't found anything because our search for extraterrestrial life has just begun. It's also entirely possible that we are the only intelligent life out here in the universe. Or maybe they're already here, but we can't sense them. Or maybe another more extreme theory. Maybe we haven't detected life because we're searching in the wrong way. Because the way we think about aliens is a direct reflection of what we are, how we live, and how we function. Maybe there's very little commonality between humans and aliens, and we need to re-examine what we look for, where we look, and the ways we attempt to communicate with other life forms. Is it possible that they have transcended the physical limits as we know and understand them? Not only beyond our human senses, but beyond the capabilities of our current technology. Could they be traveling and communicating in ways we never thought possible, or haven't yet discovered? Do they perceive space and time and base reality the same way as us? We assume they do. We assume a lot, but we have to, as it's all we have to go on. Either way, these assumptions should be explored, examined, and scrutinized. Being closed-minded and locked into our assumptions will not lead us anywhere. We will cover all that and more in this video, but first, a quick recap on the sheer size of our solar system to help get an understanding of why the search for life across space is so challenging. Part 1. The vastness of the observable universe. If you were driving at 70 miles per hour, it would take you about 15 days to drive around the equator, 5 months to drive to the moon, 63 years to drive to Mars at its closest point, and 4,400 years to drive to Neptune. The solar system alone is huge. In 1977, we sent a probe, Voyager 1, into space at 38,000 miles per hour, and it didn't exit the solar system until 2012. That's going 38,000 miles per hour for 35 years just to get out of the solar system. Even light, which can go around the planet 7 times in 1 second, is kind of slow when compared to the sheer size of the solar system. We are zooming out at about 500 times faster than the speed of light. Usually, it would take 8 hours for light from our sun to get this far, and we did it in about 1 minute. The solar system is absolutely massive. And while the solar system is immense, it's just peanuts compared to the Milky Way galaxy. The Milky Way galaxy has approximately 300 billion stars. Some, if not most, have their own family of planets orbiting them. Our closest neighboring star system, Alpha Centauri, is 4.3 light-years away. I showed this example in a previous video, but wanted to show it again because it illustrates these distances well. If our solar system, out to Neptune's orbit, was shrunk to the size of a US quarter, how far away do you think the next star system, Alpha Centauri, would be? Take a guess. If the solar system was shrunk down to the size of this quarter, the next star system would be 300 feet away. Earlier, I mentioned that it would take 4,400 years to drive to Neptune. Now, imagine how long it would take to drive to the next star. Even something going the speed of Voyager, 38,000 miles per hour, would take 77,000 years to get there. Let's take this quarter analogy to the next level. If our solar system was again shrunk down to the size of a US quarter, the entire Milky Way galaxy would be about the size of North America. And there would be another 300 billion quarters, which represent other star systems and their planets, spread out all over North America. Imagine that for a moment. Quarters spread out all over North America, approximately every 300 feet, in all directions. We are just one of these 300 billion quarters floating around in this massive sea of stars and planets. Beyond our galaxy, there are at least 1 trillion more galaxies. A trillion! That's a massive number. That's 1 million, 1 million times. Let's simplify that. Let's say you have a group of 1,000 cats. And there are 1,000 of these groups. So, 1,000 groups of cats, each with 1,000 cats in them. That's 1 million cats. Now, for 1 trillion, each and every single cat, remember, there are 1 million altogether. But each and every single cat would represent another 1 million cats. That's a lot of cat fights. A trillion is 1 million, a million times. It's an insanely huge number. This cat would represent 1 million cats. And this cat would represent another 1 million cats. Every cat here represents 1 million cats. That's how many galaxies are out there. Our nearest neighboring galaxy is the Andromeda Galaxy. The Andromeda Galaxy, which is 2.5 million light-years away, is currently speeding toward us at over 670,000 miles per hour. As it gets closer, our night sky will change drastically. Andromeda has about 1 trillion stars, and when it collides with the Milky Way and its 300 billion stars, it's actually very unlikely that even a single star from either galaxy will collide with one another. I'm sure this comes as a surprise to some, but that really illustrates the sheer amount of space between stars in the galaxy. It's more of a gravitational collision than an actual collision. Maybe these galactic collisions allow for life to travel between stars and galaxies. Galaxies are not the static systems we once believed them to be. They are a moving, breathing system. As we zoom out, we see our local group of galaxies, and then the Virgo cluster, made up of more than 1,500 galaxies. Next, the Virgo supercluster is made up of some 20,000 galaxies, but this is just a small lobe of an even bigger supercluster, Laniakea, made up of approximately 100,000 galaxies. 100,000 galaxies, each with hundreds of billions of their own stars and planets. There are another 10 million superclusters like Laniakea in the observable universe. As we keep zooming out, you will see more and more galaxies that have been mapped out. These are real galaxies and their locations, and this is just a tiny amount of what's actually out there. There are hundreds of billions more galaxies, they just haven't been mapped out yet. The dark area is called the void of obscuration. These areas are blocked from observation by dust and other stars within our own Milky Way galaxy. As the distance gets greater, the black area, or the blocked portion, gets wider and wider. The red points are also galaxies. The light from these galaxies has taken so long to travel to Earth that we are seeing these galaxies as they were at their infancy, billions of years ago. We are seeing billions of years into the past. In fact, anytime you look at the stars, you're seeing into the past. Finally, we get to the cosmic background radiation. This is the oldest light that we can detect. The residual heat left over from the Big Bang. What's beyond the observable universe? Many more galaxies exist beyond what we are able to see. We can't see them because the light emitted from them hasn't had enough time to reach Earth. Additionally, as space continues to expand and galaxies keep moving away from us, the light from most of these very distant galaxies will never be able to reach us. These areas may forever be out of our reach. How much further does the universe extend? By making inferences based on the laws of physics as we know them today, the entire universe is at least 250 times larger than the observable universe. It's at least that much bigger, and there are compelling arguments that it's even bigger and possibly infinite, but that's a topic for another day. Let's back up for a minute. Within our own observable universe, there are an estimated 300 quintillion habitable planets. So, if there are so many habitable planets, where are the aliens? If we look to the Drake equation, which estimates the probability of intelligent-based life, there are a few things to consider. First, let's take the number of habitable planets just within our own Milky Way galaxy. Conservative estimates put the number of planets in the Milky Way at about 100 billion. Of those 100 billion planets, 300 million, less than 1%, are thought to be habitable. To put the number 300 million into human context, imagine that you had a book of planets like this one. It would take a year to flip through the catalog of habitable planets in the Milky Way. And it would take 1 trillion years to flip through the book of habitable planets in the observable universe. And that's just the so-called habitable planets. The habitable zone, for life as we know it, is where the planet's surface is just the right temperature for liquid water. Not too cold and not too hot. There's a chance that life exists on planets outside of the habitable zone. For example, heat is generated in the core or through tidal shifting on some planets and moons that are outside of the habitable zone. Europa and Io, two of Jupiter's moons, are good examples of this. This tidal shifting could allow for liquid water to exist outside of the habitable zone. That said, our estimate of 300 million habitable planets could get even bigger. We will get to that later, but first, of those so-called habitable planets, how many have developed simple, microbial life? Let's talk about abiogenesis. The original evolution of living organisms from inorganic or inanimate substances. I'm going to paraphrase an article from Astronomy magazine entitled One Step at a Time. For a planet to have life as we know it, it has to contain the needed blend of fundamental elements and compounds to provide the necessary building blocks for life. Life can't just come from atoms simply smashing together at random, but life can develop over time, one step at a time. In 1955, Stanley Miller and Harold Urey mixed a few simple compounds together, carbon dioxide and ammonia, in a flask, and added a spark. From that, complex organic molecules including amino acids were formed. Amino acids are the building blocks of the proteins used in all living organisms. Other experiments have yielded similar results and have produced other biologically important compounds, including nucleotides that encode information in DNA and RNA. Other experiments have produced self-replicating molecules which then mutated into different species that competed for resources. Dr. Jeff Hester, an astrophysicist, stated, "Given a menagerie of organic molecules, emergent self-replication, non-equilibrium thermodynamics, plenty of energy, a beaker the size of Earth and millions of years, the journey from geochemistry to life doesn't look very hard." Some scientists believe that life may be so common that there are at least 10 bodies in our solar system alone that have it. Life finds a way. I believe the emergence of simple life is very common, and it's only a matter of time before we find microbes on another planet, moon or meteorite. When we do, it will become apparent that life emerges all over the cosmos, and it's saturated in bacteria and other simple life forms. But this is just an assumption which could easily end up being false. It could be that the step from non-living matter to single-cell life and multicellular life could be exceptionally rare. This could be the great filter, the idea that somewhere along the line from non-living matter to colonization explosion, there must be one step in the process that is improbable. This idea is supported by the fact that space seems dead to us. There are no indisputable signs of life. If simple life is very common, then maybe the great filter is further down the chain of evolution, such as the leap from simple life to intelligent life, which we could loosely define here as tool-using animals. Of the planets where life has emerged, how many have developed intelligent life? The emergence of intelligent life might be the hardest step. Something like the Cambrian explosion, which gave rise to most modern animal life here on Earth, could be a rare event on other planets. Intelligent life was obviously a long and difficult road that required many complex steps. But others argue that this leap is almost inevitable given the right conditions and enough time. They believe intelligent life emerges just as predictably as simple life. Could it be that intelligent and complex life forms are a natural property or a fundamental aspect of the universe itself? Of those planets where intelligent life has emerged, how many have developed a technology that releases detectable signs of their existence into space? This is where the numbers really start to drop. A few things to consider. First, how many could send signals into space? There is a vast spectrum of intelligent life. There could be millions of intelligent, tool-using species that are not yet at our level. They may be out there, but we can't detect them. There could even be millions of civilizations at our level of development, and we wouldn't even know, because like us, they can't communicate across vast distances. Our radiosphere is only 100 light-years in radius, and as you can see, there could be many non-intersecting radiospheres. And then you have many species above our level and species above their level, and on and on. We humans still fight, eat, and breed most of the time. We're still heavily dictated by our lizard brains. As much as we may deny it, we are still a primitive species. It's a wide spectrum, so we have to ask a critical question here. Could we actually detect and understand signals from some super advanced being? With detection, we assume a type of technological commensurability and that we could communicate with them using our methods. But how inevitable is our technological evolution? Our technological path is just one way of advancement, especially when you consider that there could be other elements, chemistry, and biology out there. If we did receive a signal, would we even know or understand it? There would be a huge linguistic gap as well as an intelligence gap. More on that later. Another big consideration. If they could send detectable and understandable signals, a big if, would they? They would have to blast a continuous repeating signal into space for us to detect them with current methods, and there are many reasons why a civilization wouldn't want to do this. And the last factor in the Drake equation to consider. How long have these civilizations released detectable signals into space? We've been sending signals out into space for 100 years, and those signals have reached some 15,000 star systems, just 1/20 millionth of the stars in the Milky Way. The universe is 13.8 billion years old, so there has been plenty of time for other advanced beings to permeate space with signals, if they wanted to. Clearly, there are many barriers in the journey from habitable planet to a civilization releasing detectable signals into space. If we speculate that 1% of habitable planets in our galaxy have simple life, that leaves 3 million planets, and if 1 out of 1,000 of those simple life forms evolve into intelligent life, we could have about 3,000 intelligent species in our galaxy. That's just one intelligent civilization for every 100,000 habitable planets. Or one for every 33 million planets in the whole Milky Way. This is a very conservative number in my opinion. Obviously, some of these numbers are complete guesses. Make up your own numbers and have fun with it. How many intelligent species do you think are living in our galaxy? It's all speculation and nobody really knows, but even if the chances were low at every stage, there should still be many civilizations. Our galaxy, our universe, should be teeming with life. So again, why aren't we seeing them all over the place? The curious nature of this is referred to as the Fermi Paradox. If there is so much life out there, why haven't we seen anything? Sure, there are UFO sightings and even unknown aerial phenomena acknowledged by our government, which is a topic for another day, but why isn't there any real, clear, and convincing evidence for extraterrestrial life? Why isn't it like Star Wars out there? Part 2. Hypothetical solutions for the Fermi Paradox. Number 1. The first and most obvious answer is that we are simply too far away from other species. The space between stars is just too great. Perhaps if we were closer to the center of the galaxy, where stars are closer together, the odds of an encounter would be higher. We are about 27,000 light-years from the center of the galaxy. Here, stars are scattered several light-years away from one another. But imagine living in an area closer to the center of the galaxy where there are 10 stars within 1 light-year. We're just way out here in the sticks. And not to compound this problem further, but on the galactic level we may be in what some theorize as the local hole. A less dense part of space about 2 billion light-years in diameter. If true, this would make the chances of finding life near us even more unlikely. We could be in an area as unpopulated as the desert, while other parts of the universe, like galaxy clusters, could be teeming with advanced civilizations. Not only are we too distant across space, but also across time. We are a momentary pulse in time. We have been around for a tiny fraction on the time scale of the universe. If the age of the universe was compressed to 1 calendar year, the last ice age would have ended just 1 minute ago on the cosmic calendar. The last ice age ended 25,000 years ago, and that's only 1 minute ago on the cosmic calendar. And even if we detected a species far, far away, they might be dead by the time we receive their signal because the light that reaches us is from the distant past. There could be just a handful of advanced beings in our galaxy at any given period in time, and the likelihood of us bumping into each other is slim, especially when you consider that there are hundreds of billions of planets to be examined. Maybe there are some chance encounters. Some get to meet up and others never get the chance to. Number 2. Perhaps it's not as bleak as that. An advanced civilization could, by some estimates, probe and spread over an entire galaxy in 50 million years. Given that the universe is 13.8 billion years old, that is plenty of time for several civilizations to spread out. Perhaps there are plenty of advanced beings out there, but they are leaving us alone on purpose. Why would they do that? Maybe aliens want nothing to do with us. Either because we're too simple for them to even want to communicate with, or they saw our 1-star rating and they're hanging out over at the 5-star star systems. Or we could be considered a conservation, an untouched tribe of the Amazon, but on the galactic level. They don't want us to lose our identity and culture. They want to see what we become. Or we're simply too primitive, too dualistic, and too blind to our true nature of oneness, and they are waiting for us to develop into a more advanced and peaceful species before allowing and helping us spread into the cosmos. Species either implode on themselves due to their inherently violent and destructive nature, or they explode into the cosmos as consciously evolved beings. Or we're a zoo attraction, the greatest show this side of the Milky Way. If aliens had the technology to travel here, they are clearly very advanced and likely have the technology to watch us and remain hidden from human detection. Similar to how a hunter puts up cameras to watch a deer. The deer hasn't a clue it's being watched, and neither do we. Which leads to the next theory. Number 3. They're already here, but we just can't see them. There could be one in your room, studying you right now, and you wouldn't even know it. Again, if they could travel to another star system light years away from their planet, then they would also have technology advanced enough to achieve some kind of cloaking. And now that you are freaked out, I will add this. For a species to advance to the point where they can travel great distances, they would have to be altruistic. I believe it's the natural filter of the cosmos. Consciously superior beings are allowed out of their solar system cage. These civilizations have developed well beyond internal fighting and divisions among their own species. Something that we humans need to learn. These beings are advanced enough that they don't need to fight over resources. There are endless planets and asteroids to mine or harvest, and not to mention billions of stars they can gather energy from. They don't need our resources. The problem with thinking about aliens is that we apply our level of maturity and development to them. It makes sense why we do this. We are the only life we know of, and we have a very dualistic nature. The "I'm an independent creature and I must survive" mentality. The old lizard brain, but again, that mentality is probably not accurate of a super advanced species that have a better understanding of their place in the universe. Their inherent unity and interconnectedness with the cosmos. So, don't worry if there are aliens in your room, they are probably peaceful. But I will admit that this is a hopeful assumption of mine. We don't know if other species are altruistic. We have no way of knowing how an alien would think. We don't know their motives. To them we may be nothing more than some planetary bacteria, and they won't think twice about wiping us out in order to build their intergalactic superhighway. One more tangent before moving on to the next theory. Aliens could be in our solar system right now. Some believe that they could be living at the edge of our solar system in the Kuiper Belt. The Kuiper Belt is made up of millions of objects from small bodies to dwarf-sized planets, like Pluto and Eris. If some advanced life form wanted to live in a space habitat and remain hidden, this would be an excellent place to do so. Number 4. We haven't detected aliens because we are at the beginning of our search. It takes a ton of time and resources to search for extraterrestrial life, and what we have done thus far is just a drop in the bucket. We've barely begun the search. Even with all the work done by SETI, METI, Breakthrough Listen Project, and other groups, we've barely scratched the surface. We are scanning the skies for radio signals, repeating radio bursts that are designed to attract attention, and we are looking within a very specific window of time. The search is hindered by many limits such as sensitivity, frequency range, the types of signals the equipment can detect, and of course the number of stars we can observe. Additionally, our search for exoplanets is in its infancy. Many stars have planets, but they are incredibly hard to detect. They are very dim as they only reflect light, so the main method we use to find them is to look for dips in the star's brightness as a planet passes in front of it. But we have to be on the right plane for that to work. Only about 1% of exoplanets are on the plane that allows us to see them crossing over their star. Other techniques are in development like radial velocity, direct imaging, gravitational microlensing, and others, but our techniques are still wanting. Recently, it was also discovered that there are rogue planets, planets similar in size to Jupiter, that do not orbit a star. There could be millions of these rogue planets floating through the cosmos. Maybe this is one way the star systems spread their seed throughout the cosmos. The bottom line is, we are still just beginning our search. This is why it's so difficult to estimate how many planets are orbiting other stars and how many are in the habitable zone. In the early stages of our search, we have to be careful not to jump to conclusions based on very limited data. You don't just take a cup of water from the ocean, examine it, see nothing, and declare that there is no life in the ocean. So why do that with the universe? In truth, we have a long way to go. People are working hard to make progress, and I'm hopeful that we'll detect something soon. Maybe even with the recently launched James Webb Space Telescope. Number 5. The Transcension Hypothesis. When aliens get to a certain level of development, they don't expand into the galaxy as we assume they would. They have no desire to waste their efforts in exploring other regions of space. Instead, they move towards something like an inner space. Vast digital realities on computers. Basically, they live in video game universes of unimaginable brilliance. Or as futurist John Smart stated, the Transcension Hypothesis proposes that a universal process of evolutionary development guides all sufficiently advanced civilizations into what may be called inner space, a computationally optimal domain of increasingly dense, productive, miniaturized, and efficient scales of space, time, energy, and matter, and eventually, to a black hole-like destination. If these beings have moved beyond the space-time environment altogether, how would they perceive the universe? They would have a very different perspective of reality, and would be beyond our detection. If a universal process of evolutionary development guides all sufficiently advanced civilizations, then this could be our path into the future as well. Number 6. We are the first intelligent life out here in the universe. Either because we have a very unique planet, the rare Earth hypothesis, or because we're early to the party. First, the rare Earth hypothesis. There are many reasons to think our Earth is uniquely suited for complex life, from our planet's composition, atmosphere, magnetic field, and plate tectonics, to our planet's orbital distance, large moon, stable orbit, and the arrangement of planets around us. But there are also many arguments against this hypothesis. The most important being that we simply don't have enough data on exoplanets to claim any of these are true. We used to say solar systems are rare. We were wrong. We used to say planets are rare. We were wrong again. We used to say there aren't many rocky planets. Wrong once again. We used to say that there aren't many planets in the habitable zone. Wrong yet again. I see a pattern here. What else will be proven wrong in the future? We're constantly discovering rocky exoplanets around main sequence stars, and there is no evidence to suggest that these other planets don't have plate tectonics, stable orbits, or a magnetic field. Assuming Earth-like planets are rare is simply assuming too much. We think Earth is special and unique, but that's just a reflection of our own self-importance. We think it's special and different, but it's really not. There is no evidence to say that there is something special about this solar system or this planet. It's also very unimaginative to claim that life can only arise on an Earth-like planet. The rare Earth hypothesis isn't a hypothesis, it's just a description of how life evolved on Earth. Complex life may arise in alternative habitats. More on that later. Second, we're the only intelligent life out here because we're early to the party. We are the firstborn. At some point when the universe was young, there was the first intelligent life, and they were in fact the only intelligent life in the universe. They really were, all alone. Given the age of the universe, I don't think that's true for us. Why, you ask? Again, the universe is 13.8 billion years old. Our planet is 4.5 billion years old. It took a few 100 million years for simple life to appear, and about 4 billion years for complex life to arise. So, simple life on Earth has been around for 1/3 of the universe. Complex life on Earth has been around for 1/30th of the universe. And we humans have been around for even less time, about 1/70,000th of the universe. Let's go back to the Big Bang for a moment. It took 100 million years for the first stars to appear, and the first galaxies formed around 500 million years after the Big Bang. Initially, it was thought that stars didn't produce enough star stuff to build terrestrial planets until 6 or 7 billion years after the Big Bang, but NASA's Kepler changed this idea, and in short, planets that could potentially support life may have been around as early as 12 billion years ago. Considering all that, intelligent life was probably around long before we were here. And maybe the Earth was seeded by one of these earlier life forms. With that said, in the grand scheme of the timeline of the universe, which could go on for another 1 trillion years, we are actually early to the party. So, let's not screw this up. We could be the early ancestors in a long series of life forms to come. Let's take another quick tangent and consider one potential and somewhat frightening future evolutionary timeline. You could envision that organic life forms, like us, learn to surpass our fragile bodies by integrating new robotic technologies and AI. From there, we would be able to evolve at an exceedingly rapid pace until we're barely, if at all, organic anymore. As communications theorist Marshall McLuhan put it, man becomes, as it were, the reproductive organs of the machine world. We are the vehicle of which machines evolve. Organic beings, like us, could be an early and necessary step in the evolutionary timeline of advanced beings. If we kept evolving for millions of years as some inorganic intelligence, our current, organic human-level intelligence would be a very brief interlude in our evolutionary history. If this were true, then the chances of finding organic beings are slim. We assume they are organic, because that's how we are today, but what if they surpassed that stage long ago? There is a chance that advanced aliens are AI, virtual, or robotic in nature. If you consider how hazardous space is to biological creatures and how much better machine-like beings can operate in space, it's not a far-fetched idea. Maybe these advanced quantum robot gods are not in some artificial state keeping to themselves. Perhaps there are galaxies full of self-replicating machines, spreading out into the cosmos. Machine intelligences could live anywhere, which means that we should expand the parameters of our search. We should look for techno-signatures within the habitable zone as well as outside of it. Could our first alien contact be virtual, AI, or robotic in nature? Is it possible that our first contact will be via someone's computer, smartphone, or some other technology? Which leads to the next theory. Part 3. Our flawed assumptions. Is it possible that we're not finding life because we're going about it all wrong? In the search for extraterrestrial life, we're focusing our resources on life as we know it. We are looking for planets with liquid water as well as the biosignatures of alien microbes and searching for intelligent life with radio signals. This is obviously our best bet, but let's keep an open mind here and reassess the types of life we're looking for, the places they could be living, and the ways that we're trying to communicate. In the search for life, we should deeply contemplate the question, What exactly are we looking for? This is a tough question because it's limited by our human imagination and our assumptions. It's also a profound question because it challenges our understanding of what intelligence is and what being alive really means. We tend to think of other aliens as being similar to us, but will some alien species fit the model of life as we know it? As wet biological systems. Life as we know it is just how Earth went about creating life. Much in the same way a tree produces apples, the Earth produces human beings. It's possible that different planetary conditions, such as orbit, rotation, gravity, chemical composition, and atmosphere could give rise to very strange life forms. Carbon, which is what you and I are made of, can form bonds with up to 4 other atoms at the same time. This enables it to form long chains of molecules and makes life as we know it possible. Life beyond Earth may not necessarily use carbon-based molecules as its building block. Let's explore a few hypothetical types of biochemistries. Other life forms may be silicon-based and depend on ammonia or methane as their solvent, instead of water. They could also be plasma-based. Physicists have created blobs of gaseous plasma that can grow, replicate, and communicate. Physicists have also suggested that under the right conditions, inorganic dust particles suspended in a plasma can organize into helical structures and interact with each other. They can attract, divide, form copies, induce changes in their neighbors, and evolve. Sure, this is not some advanced species, but it does show how limited our knowledge and parameters are, and how other life forms could be vastly different from what we assume them to be. Other life forms could be boron-based, ammonia-based, sulfur-based, or even a type of gaseous life form unknown to us. There could be nanoscale aliens or RNA-based life forms that we can't even see. There's even been some speculation about exotic biochemistries based on complex metal oxides. And there are even more extreme theories that large complex structures of stars and galaxies themselves may have a type of intelligence that we do not yet understand. Intelligence may come in forms and variations that we can't really make sense of or understand. There could be some intelligent species that simply doesn't think, behave, or look like us because their environment produced a very different kind of species with a very different brain structure. Because of our extreme differences, it may be very difficult for us to realize that there is an intelligence there to begin with. What's possible outside of how we narrowly define life and intelligence here on Earth? This is important because it challenges our whole concept on what intelligence is and what being alive means. Does something need to think as we think to be considered intelligent, alive, and aware? Alien life may not meet our strict definition, but it could be alive and intelligent in a different way. In a way, dare I say it, that is alien to us. Perhaps they do evolve like us. Maybe there is a type of universal convergent evolution. I hope some of them are like us, at least somewhat. That would be amazing. We could learn so much from them. But be open to the idea that maybe they aren't, especially when you consider what a different environment, gravity, orbit, chemistry, and atmosphere would do to an organism. When humans go to Mars and live there in the next couple decades, they will start morphing to fit their environment. Who knows what they will look like in just a few generations? Just as the search for life is limited to a narrow range, the areas we look for life is also limited to a small range. Most of space is too cold or too hot for life as we know it. It's outside of the so-called habitable zone. These assumptions could, again, be leading us in the wrong direction. This is becoming more and more apparent because everywhere we look for life on Earth, we find it. From microbes 6 miles underground, to bacteria in the Arctic permafrost, to species living underwater near boiling hot vents, life finds a way. Strange and exotic life forms could exist outside of the habitable zone. And just as alien worlds could be hostile to life as we know it, our planet could be hostile to alien life forms as well. It may be possible for life to form on exotic exoplanets outside of the currently accepted candidates, like terrestrial planets and super-Earth planets. Hot mini-Neptunes, which are planets with a hydrogen atmosphere covered in oceans, as well as gas giants, frozen worlds, and even brown dwarfs could potentially harbor life. And as mentioned earlier, AI could live anywhere, so maybe we should consider where they may be hanging out in our search for life. Would they be better off near energy-rich stars, or would they do better in the deeper, cooler parts of space? And of course, the way we try to communicate with alien life may be fundamentally flawed. It may be the case that we haven't communicated with any aliens because we're using the wrong methods. For the last 50+ years, we've assumed that aliens use radio waves to communicate, but they probably left that form of communication long ago. Electromagnetic radiation was only discovered and understood about 150 years ago by James Maxwell and others. 150 years is nothing, that's just 2 lifetimes. We're in the very early stages of our technological and scientific journey. Aliens could be trying to communicate using a different wavelength on the electromagnetic spectrum, like ultraviolet light, optical lasers, X-rays, or they may be using other methods like megastructures, gravity waves, or even neutrinos. Trillions of neutrinos pass through you and the planet every second and don't touch a single atom. Aliens could be using these to communicate with us right now, and we wouldn't even know it. The speed of light, which all those examples are restricted to, may be too slow a method to meaningfully communicate. Yes, I know this is taboo thinking because nothing that we know of can go faster than light, but here is the problem. Communicating with aliens in our galaxy, in the ways we know how, would take anywhere from a decade to 80,000 years. And that's just one way. Even if they were only 10,000 light-years away, their signal would still take 10,000 years to reach us. They could very well be extinct by the time we get a signal. Communication on the galactical level would take millions of years or more. Some species may be using older methods like radio waves, but most advanced civilizations are communicating via some kind of quantum communication, distortions of space-time, a higher level of consciousness, or some other phenomena we have yet to discover. If they do decide to communicate with us, I imagine that it will be in a way that we never envisioned. In a surprising way. This circles back to our assumptions of what aliens would be like. What would some bizarre life form use to communicate? Did they evolve in a technologically similar way to us? If they are vastly different in chemical composition and brain structure, then it's going to be extremely difficult to imagine how they communicate. A brain structure that is vastly different from ours may have different organs of perception altogether. If the universe is indeed quantum fields, fluctuations of energy propagating throughout time and space, then those vibrations could be perceived in many different ways. There's no guarantee that alien brains perceive spacetime as human brains do. Needless to say, all of these differences would produce entirely different communication methods. Let me expand on one of our biggest assumptions when it comes to communicating with aliens that I touched on earlier. If we did make contact, would we be able to communicate with them in a meaningful way? We believe that we could communicate with aliens, but it's much tougher than we assume. Humans use language via a narrow range of sound waves to communicate. Some animals, like tarsiers, use sound waves well above our ears' detection range. African elephants use a sound so low that we can't hear it, but other elephants can hear it up to 175 miles away. Other species use completely different senses to communicate. For example, electric fish discharge electricity, dogs use their sense of smell, ants use pheromones, mantis shrimp flash lights, and dolphins use echolocation and clicking. Dolphins are extremely intelligent, and we can't really communicate with them. With that in mind, we shouldn't expect that we will be able to communicate with some carbon-based being, with a completely different evolutionary path than us, let alone some hive-minded creature with a silicon biology. To assume that we can communicate with some alien species is naive. We can barely communicate with anything on our own planet. Even if early hominids, our evolutionary ancestors, were alive today, we wouldn't be able to communicate with them very well. We can barely communicate with our great ape relatives. We can hardly understand some ancient languages from our own species. So, what makes us think that we could communicate with aliens from an entirely different planet? If you say, no, we are super intelligent, and we would understand aliens, you must understand something. To advanced aliens, We are much dumber than an ape is to us. Or even worse. To them, we may be as dumb as ants are to us. With an intellectual gap like that, we wouldn't understand the communication, and we may not even realize that we are being communicated with. Does an ant know when a higher intelligence is trying to interact with it? Let's get a little wild with this one. There could be a higher intelligence guiding you and interacting with you right now, in ways that are beyond our current scientific understanding and beyond the natural and physical world as we know and understand them. The assumptions of our current scientific paradigm. We're constantly applying the technologies of our time to how we think aliens will be, and how they will behave, which is understandable because it's all we know, but this really limits the possibilities. For example, we believe aliens would travel vast distances in spaceships. Long ago, people thought aliens came in some kind of flying boat because that was the extent of their technology at the time. But why assume they are using physical spaceships in the way we think they are? They're not going to travel here in a physical ship, land on the White House lawn and ask to speak with our leader. The way we think of aliens is a reflection of what we are and how we live. In 200 years, we'll have new metaphors depicting what aliens are like and how they travel. Right now, we're thinking too much on the physical plane, on what we can sense and where our science and technology is today. That's probably why we haven't made contact yet. Advanced aliens capable of interstellar travel are well beyond the physical world as we know and understand it today. Let me speculate for a moment. As we evolved, we only knew of our human senses, and then new instruments and methods were made to investigate our world at a deeper level, and amazing discoveries were made. We found out that there are plenty of things beyond the limits of human perception. Technology clearly shows us the limits of human perception all the time. Technology enabled us to detect all kinds of electromagnetic radiation outside of visible light, like infrared, X-rays, radio waves, and gamma rays. Technology also enabled us to detect infra and ultrasound, strong magnetic fields, things too small to see, things too far away, and things that are too slow to see with the naked eye, like continental drift and the movement of the stars relative to each other. We surpassed our human limitations through technology. We turn to technology to help us see and understand more about the world, but who says we are at the end of the road to discovery? Our understanding of the universe is a moving target, and in fact, there are still plenty of gaps and inconsistencies in our scientific model of the universe. There are plenty of anomalies and things that are poorly understood or simply can't be explained. We should remember that science is a model of reality based on data points. It is based on what we know via observation and experimentation. It's constantly being updated, and the boundaries of science are always expanding. Science produces a very loose model of reality that is incomplete, not all-encompassing, and full of well-reasoned, but unproven theories. We still have a very long way to go. To assume otherwise is to delude ourselves. It's worth noting Thomas Kuhn's work here. He showed that scientific breakthroughs and new understandings don't arise from working within the current scientific paradigm. Breakthroughs occur when an accumulation of anomalies leads scientists to question the current scientific model. They poke and prod the paradigm, have thought experiments, and explore wild ideas, until a new revolutionary paradigm arises. This isn't just a nice idea. This has happened many times, from the geocentric model of the solar system, to the Copernican, to Newtonian mechanics, to Einstein's special and general relativity, and quantum mechanics, which we still don't quite understand. What's the next paradigm shift? If history has taught us anything, it's to assume that we haven't reached a complete understanding or anything close to it. Let's be real, we don't know what gravity is. Our ideas of gravity could be wrong. We don't know what dark matter and dark energy are, and they supposedly make up 95% of the universe. We don't even know what energy is. We only know that it is the thing that is always conserved. We can describe the behavior of things like atoms, but we don't actually know what they are at the deepest level. Many of our theories are just theories. They are our best fit, but they could be wrong or at the very least, incomplete. And to add even more uncertainty, we don't know what we don't know. We should assume that there is an enormous number of phenomena that our instruments can't yet detect because those instruments don't yet exist. The phenomena are beyond our current understanding and therefore beyond any conventional method of observation or experimentation. A great example of this is Michael Faraday's discovery of magnetic induction. He showed that invisible field lines of energy are responsible for the relationship between electrical currents and magnets. At the time, in 1831, this sounded like nonsense. It sounded like malevolent magic or make-believe because we simply didn't understand invisible forces at the time. Faraday was kind of a laughingstock until James Maxwell confirmed that electromagnetism is in fact a field phenomenon. What exists that we don't yet understand? What exists that we can't yet detect? What else is out there? How will we learn of these new areas and how will we incorporate them into our world? Actually, we can speculate a little bit on this now with quantum theory. Most of us, the masses, still believe that reality is material and that we are physical beings. Quantum physics tells us that reality is more like interacting fields of waves, and this blew the mechanistic material worldview out of the water over 100 years ago. But we are very much stuck in this physical and material mindset. That is just how our brains are hardwired, but reality is not a physical thing as we're conditioned to believe. As Einstein said, reality is merely an illusion, albeit a very persistent one. Now, imagine once we really understand and internalize the implications of quantum theory or some other deeper and more accurate theory. Once we develop the technology that takes advantage of this knowledge and incorporate these ideas into our lives and society, we will be almost unrecognizable. Can we even imagine how advanced our understanding of physics will be in the future? How advanced our understanding of nature and reality will be in 1,000 years? Scientists will find new ways to probe the universe which could give rise to new paradigms and new ways of thinking and being. We don't know what our evolutionary path looks like. But we understand that as things evolve in nature, they develop new capabilities, features, and tools. As we continue to evolve, we will develop capabilities and features in the form of new technologies and maybe even organs of higher perception. We may go from flesh to cyborg to a godlike machine or to a higher form of consciousness. Even to the point where we go beyond the temporal domain. We simply don't know. Is it possible that this is what happens to advanced beings? Could it be that they pass through this phase we are in now in a relatively short period of time, maybe several thousand years, and moved on in ways we can't even imagine? The technology that advanced aliens possess would look like magic to us, just as a cell phone would look like magic to someone from the 1800s. Considering all this, interstellar beings may not be traveling here in physical ships. They are likely traveling and attempting to communicate in ways we can't comprehend of now, either using some advanced technology as discussed earlier, or using another sense we're currently unaware of through organs of a different or higher perception. Or maybe they are traveling and communicating via deeper forms of consciousness. We don't know what consciousness is. We don't actually know if it arises in the brain, or if our brains are like antennae that are tapping into consciousness itself. We don't know as much as we like to think we do, so we must always be radically open-minded to the possibilities. Some advanced beings may have even progressed beyond these levels, into a place beyond space-time. They have evolved beyond our senses and perception altogether. Basically, they've leveled up into a higher dimension, realm, consciousness, or whatever you want to call it. The physical universe as we know it could just be the ground state. In our search, we must attempt to think outside of the norms. We must remember that we are limited by our imagination, our assumptions, and by our understanding of physics. This all sounds very sci-fi, but when you consider how weird reality is, how weird our very existence is it really so strange? I'm not saying any one theory is wrong or right. There are many possibilities. Be open to them because we're always expanding our knowledge of the universe. We're always discovering how we are wrong. There are paradigm shifts every couple hundred years. What do you think will be proven wrong in the next paradigm shift? Conclusion. There is no doubt that we are in a bizarre predicament. Why are there no signs of alien life? There are thousands of theories to choose from. Pick your favorite. Let your imagination run wild and let me know your theory down in the comments. The universe is big enough for most of the theories in this video to be true. Why is the question, are we alone, so intriguing? It's because it's really about us and our place in the cosmos. The answer to this question would help us to understand who we are, what we are, and give us more insight into why we're here. Finding life would radically change how we see ourselves, upend our worldview, and alter our values as a society. Even with all these crazy theories and wild speculation about aliens, there is a bigger picture here. What is the universe? What are we? After watching this video, you can think a couple things. 1. I'm this tiny separate thing on a distant planet in the middle of nowhere special. I'll live for several decades and then die, and that will be that. Or 2. You may be thinking, wow, I'm a part of this unimaginably large, possibly infinite universe that is potentially teeming with life. A part of this thing that I don't really understand. A thing that, well, no one truly understands. A part of this planet. A part of this node in the sea of space that is coming to life. And things can get very metaphysical after that. Within our current scientific understanding, it's easy to feel alone in the universe. We believe that we are separate beings, floating around on a tiny rock in a vast and seemingly dead universe. This is an old and outdated paradigm that needs to be updated. We need to re-examine a few key assumptions and learn to let go of these old beliefs for ourselves and for humanity. I'll be covering these key assumptions in future videos, but to give you a sneak peek. First, the idea that you are somehow separate from the universe needs to be obliterated. We are taught that we are individuals, separate from the world out there. Of course, with assumptions and beliefs like that, you will feel like a lost soul, but it doesn't have to be that way. Although we feel that we are independent creatures roaming around, we're not really separate. We're not independent of the world we live in. We are in an intimate, inseparable, symbiotic relationship with the world. Humans and nature are one and the same. We are actually a part of it. A piece of the whole. The universe is not outside of you. You are in it. You're a function of the universe in the same way that one of your skin cells is a function of your whole body. We are an aspect of the universe, so it doesn't make any sense to set yourself apart and say you're an isolated object surrounded by a vast alien entity. You grew from that entity and you're inseparable from it. If you ever feel lost, just remember that the force that guides the stars guides you too. You are a result of nature just as much as a star or planet is. If you're resistant to this and only believe in cold hard science, then consider that we are all made of the same fundamental particles. Or as Carl Sagan said, the cosmos is within us. We are made of stardust. We are a way for the universe to know itself. We are all part of one thing. The same thing. Or if you want to go deeper than that, let's consider what quantum theory says. Everything in reality is made up of unified fields of fluctuating energy propagating throughout time and space. We are all a part of this unified set of fields, inseparable from it. If the universe started as a singularity, then every particle was together and able to communicate with every other particle. You are the universe perceiving itself. The implications of this are extreme. It means that you, the real you, is everything that you see and much, much more. We'll explore that in another video. The second key assumption that needs to be re-examined is our narrow definition of what life is. The distinction between living and non-living is a definitional difference. This division is actually just a concept in our minds, which is why there is so much debate on what is considered to be alive. For example, some say viruses are alive, while others say they are not. Our line between living and non-living always seems to be moving. It's always expanding outwards. We used to think that we were the only intelligent living things. Then we expanded it from ourselves to animals, insects, plants, cells, and now we're asking, are viruses, bacteria, endospores, and DNA alive in a sense? There is no clear consensus on what life is because there really is no clear line where you can say this is living and this is not. We have definitions of what we think is required for something to be alive, life as we know it, but it's a very incomplete understanding of what intelligence is and what being alive means. What if life is more inherent and fundamental to the universe than we've assumed? The universe is not some static mechanistic material thing that we once believed it to be. It's not a bunch of dumb matter floating around aimlessly. The idea of the universe being like a machine grew out of Newton's ideas of a clockwork universe. We now know that the universe is not static like a clock. It is a process of constant change, a process of movement and evolution. The universe is more comparable to an organism than a clock. I'm not saying the universe is an organism. I'm simply stating that it behaves more like an organism than a clock. Could it be that the universe itself has some type of intelligence, awareness, or a different type of consciousness than our own? Is it possible that the universe is alive in a way that isn't quite clear to us from our tiny perspective, in a way beyond our ability to comprehend? Kind of like how a cell in our body doesn't know that it is part of a larger, more complex being. This idea ties nicely into the previous idea that we are not separate from the universe. If we are intelligent and alive and not separate from the universe, then it would be logical to conclude that the universe is also intelligent and alive in a sense. In my opinion, a living being cannot be the product of a dead universe. This too will be covered in more depth in a future video. There are obviously many arguments and counterarguments to be made here, but do not discard these ideas right away. That will keep you in a perpetual cycle of paradigm lock. Reflect on it for a while before making a knee-jerk reaction based on your belief system. That's why things are constantly shut down. People get sucked into their belief system and won't consider other points of view, so be careful not to make that mistake. It is scary to challenge the beliefs that shape your entire reality, but keep an open mind and be open to new information even if it conflicts with your current paradigm. I'm not trying to convert anyone. I'm just giving a different perspective. A new perspective that you may have never heard before. One that may resonate with you more than the old, there is a God outside of the universe controlling everything. Or the more modern worldview. We are in a dead, mechanical, materialistic universe. Now, I'm not saying that there isn't a higher power. There could be many types of higher powers that are guiding us. For example, the planet is much more intelligent than we have assumed when we broke it down into our silly little models. Our models are far too simplistic to capture and understand the true intelligence of the planet, stars, and universe. It is a different type of intelligence, which is why we don't really understand it. What we have done is taken something extremely complex and in an effort to try and understand it, we made some simplistic models about its behavior. Then we looked at those models and said, that's all it is. We've forgotten that we oversimplified everything. Now, when we look at the simple models, we say, this planet is pretty simple and dumb, isn't it? It isn't. We're the silly ones for taking a very complex thing beyond our understanding and dumbing it down to an oversimplified model, and then assuming that's all it is. We are just barely beginning to understand what this planet is. We could be living on an intelligent planet, in an intelligent galaxy, in an intelligent universe, which is the manifestation of an intelligence beyond the physical universe. We know nothing, so we must be open to anything. We can debate these ideas all day, but in the end, I believe that we desperately need a new, updated model of the world. One in which we are not separate beings living in a dead universe. Our worldview, our belief system, is at the core of who and what we are. It directly shapes our culture and value system. With that said, which worldview would better serve humanity going forward? One in which we believe that we are all a part of this intelligent, possibly living system? A worldview in which each and every part is just as important, valuable, and worthy as the next. Each with its own purpose and mission. Each just as perfect and contributing towards the whole in their own unique way. Each of us are here for a short time, enjoying our unique journey through the cosmos. And when we're done here, we'll be going back to the source. The greater you, from whence you came. Or a worldview where we believe we are all separate beings living in a dead universe. One which breeds a selfish, us against them mentality. A worldview that creates fear because we believe we are independent beings in a hostile world. I think we can see how that is going, but I do believe it's just part of the evolutionary process. We'll move beyond this paradigm at some point. These are just my opinions based on my experiences. You are, of course, entitled to your own opinions, and I respect them as well. We all have the freedom to choose our own views. These topics will be covered in greater detail in future videos, so please consider checking them out. If you think this video was stellar, please drop a like.